Hi, everybody. It's Mrs. Pendleton again. I wanted to do a video for you to help you with the lab if you're distance learning because you aren't able to do the work in class. I'll do it for you. I've sent out some documents, and all I want back from you is going to be this worksheet. It says results and conclusions. That's the only part that I'm going to grade. But I sent out the other information because that's what a lab report is supposed to be like. And I also gave you background questions. There's 4 paragraphs. That's the kind of stuff you should know for the next test. So I'm not asking you to write about it for the lab report, but I do need you to know what those answers to those questions are. So in this week's lesson, we're talking about chemical bonding. I'm talking about 2 kinds of bonding today. The first one is called ionic bonding, and that happens when you get a metal and a nonmetal. Now, the metals have extra valence electrons and they give them away. When they give away their valence electrons, they form a positive charge. Nonmetals are on the right-hand side of the periodic table. What happens is they gain electrons and they form a negative charge. So when the positive metal and the negative nonmetal get together, they form a nice tight ionic bond. Ionic bonds have metals and nonmetals, both. The second type of bonding is called covalent bonding. Covalent bonding happens when there are nonmetals, and the nonmetals are pulling on the electrons. They both want the electrons real bad, so they share the electrons. Now, based on whether it's ionic and they've transferred the electrons, or covalent, where they share electrons, they will have different chemical and physical properties. Ionic compounds, because there's a cation and an anion, it's like a battery. It can circulate electricity or conduct electricity. With a molecular compound or a covalent bond, they're sharing the electrons, and so they're not able to conduct electricity like an ionic bond would. So in today's lab, I'm going to use an electrical conductivity meter, and it's going to light up right here if the solution can conduct electricity. Now there's 2 lights, there's red and green. If they both light up and it's bright, it's a good conductor, high conductivity. If it's lighting up but the lights aren't very bright, that's medium. And then if it barely lights up at all, or maybe it doesn't light up, then it's a poor conductor or a low conductor. Everybody needs to have this document, either a paper copy, or I did this on Google Classroom. I did a Google Doc so you can type on it. You can put your answers in this table. Okay, again, this is the only thing I'm grading. The rest of the lab report is for information. It shows you the names and formulas of the chemicals that I'm using today. It tells you information in the background that you should know for a test. It shows you what a lab report is supposed to be like: title, purpose, background, materials, procedures, and then results and conclusions. Okay, I want this by the end of the week. Okay, I'm going to use the electrical conductivity meter now. The first thing we have here is called distilled water. All right, distilled water has been boiled and the minerals that are in it were left behind. All right, so I'm going to put my electrical conductivity meter in the distilled water, and I see a light, but it's very dull. Okay, not a good conductor. Okay, let's try that again. Okay, see, not a good conductor. The second container has tap water. This is right from the faucet. And tap water has dissolved minerals in it. And sure enough, the minerals will conduct electricity. Now, what you can't see is that at the bottom, near the metals that are in the water, it's producing bubbles. Okay, that tells me that electricity is being conducted, so I can see bubbles. This is salt water. Now, what I did is I took regular salt and I put it in distilled water, and I made a solution. Okay, a solution is a homogeneous mixture. And when I dissolve a solid into a liquid, that's considered to be aqueous, dissolved in water. Okay, salt is a really good conductor. Now, what you need to ask yourself is, do you see a metal? And the metal will always be the first element. Sodium is an alkali metal. So this is a metal and a nonmetal. So this is a very good conductor. It is ionic. Okay, this is vinegar. It's also called acetic acid. And the thing is, it's all nonmetals. And so you might say to yourself, well, it's all nonmetal, so it shouldn't conduct. But yet it does a little bit. Okay, let me try that again. All right, so it conducts a little bit, not very good. This is kind of a medium conductor. Now, what happens with acids is that when they're in solution or when they're liquid, the first part of the molecule dissociates or breaks apart from the second part of the molecule. And so it acts like an ionic compound. All right, acids fool you. All right, you want to say that they're covalent because you don't see metals, but then they act like they should have ionic bonding. Okay, this is sodium bicarbonate. This is also called baking soda. And it's a good conductor. I can see bubbles. I see a metal. As soon as I see a metal, I know it's going to be ionic. It's going to conduct. Okay, this is sucrose. This is sugar. You might eat this for breakfast on your cereal. Okay, I don't see any lights this time. I don't see any metals. Carbon, hydrogen, and oxygen are all nonmetals, so it's not going to be a good conductor. Okay, the last one. Do you see a metal? If you see a metal, it's going to be what type of bond? You got to have one of each. Okay, what type of bond is it going to be? Okay, that's a pretty good conductor. That was a bright light. All right, that's my demonstration. That's going to help you fill out the data table and answer the conclusion questions. Get that to me by the end of the week. Thanks a lot.